This is the third part for the video lecture for the chapter number 6 AC. Now the question number 2, if the voltage of an AC source is given as, so the value of the voltage is given here. Actually here the number is not given in this question. The voltage of the AC source is given in this form. Okay, this is a source voltage. It is not a number here. Okay, sometimes some numbers are given. Okay, so here it is given in the form of the equation like that. Okay, so actually the this voltage, this should be like this. Okay, actually here it is hidden. Okay, so this voltage is a instantaneous voltage. This you have to understand from the type of the, okay, from the type of the question. This is an instantaneous voltage, I know. Okay, now, okay, so what they okay, so here there are three parts are there for this question. Calculate the maximum voltage, and calculate the RMS voltage, and calculate the frequency of the AC source. Okay, so these three things we have to find now. Okay, so what is the strategy, okay, to find the answer this kind of question if the value of the voltage is given like this? Okay, so here what you have to do, here I will write, okay, here I will write the formula for the instantaneous voltage. Okay, so this is the formula for the instantaneous voltage. So this is V. Okay, and for the instantaneous I have to write in the bracket like this time. Okay, because this voltage is a function of the time. Okay, like that. Okay, so this is equal to V maximum. This is the formula, and this is sine in the bracket. This is 2 pi f and t. Okay, sometimes it is omega t. Okay, this is 2 pi f. I can write this as a omega. Okay, so this form is also there. Now what it is given to us, okay, in the question this is given to us. Okay, so what I will do, I will write this information below. Okay, so what it is given, okay, it is given the voltage equal to, this is 350, and then multiply by sine. Okay, so this is sine, and in the bracket it is given 100t. Okay, this is given 100t. Now, okay, so here what we have to do, we have to compare. Okay, we have to compare what is, okay, what it is coming at this position. Okay, what it is coming, okay, what it is coming at this position, okay, in the equation and in the given information. So at the place of the V maximum, this number is coming. Okay, so the meaning is, okay, so the meaning is, now this is the answer for the part A. Okay, so after the comparison, okay, this is, see, this is the formula. Okay, this is a rule, this is a formula, and this information is given. Okay, this information is given in the problem. So what I am going to do here, just I am comparing the two informations. Okay, just I am comparing, okay, the two information. So here I am comparing this part. Okay, I am comparing this part, so this will give me the value of the maximum voltage. Okay, so that would be equal to 350 volt. So this is the answer for the maximum voltage. Okay, now we have to move for the, part number B. Okay, part number B means we have to find what is the value of the RMS voltage. Okay, so this RMS voltage we can find by using the rule. Okay, by using the formula, and the formula for this is the V maximum. Okay, so we need the value of the V maximum, which we found in the part A. V maximum divided by root 2. This is the rule. Okay, now we will go to the next page. Okay, so here for the solution of the part B. Okay, so here we have to find the RMS value of the voltage. Okay, Now I first I need to write the rule. So what is the rule here? What is the formula here? The formula here is, okay, the formula here is, this is the RMS voltage is, it is equal to the V maximum, and this is divided by root 2. Okay, so this is the rule, this is the rule. Okay, now I know, okay, from the part A, the value of the V maximum is coming 350 volt, and this I need to divide by root 2. Okay, so this will be how much? Okay, so if I calculate in my calculator, so this will be 247. Okay, so this will be 247.48 volt. Okay, so this is the value of the, this is the value of the vrms. The vrms is, it will come 247.48 volt. So this is the answer for the part B. Okay, now how many parts are there? Yeah. Okay, so here, for the part C, okay, what we need to do for the part C, I need to, okay, I need to compare. Okay, so again I need to compare to find the value of the, okay, to find the value of this frequency. Okay, frequency means F. Okay, and for example, okay, for example, if the question says, okay, if, okay, so if the question says what is the value of the frequency, okay, so it means you have to find the value of the F. Okay, if the question says what is the value, okay, sometimes they may say, okay, what is the value of the angular frequency, okay, then you have to find the value of the omega. Okay, so here they are saying what is the value of the, what is the value of the frequency, so I need to find this. Okay, so okay, so I will go back and then I will compare, okay, which part of the formula and which part of the given, okay, this one. So here, what I will compare, okay, I will compare this part, okay, for the frequency, okay, this part and this part. So okay, so comparison I will do. So I will write here, this is sine, and this will be 2 pi f, and this is multiplied by the time t, and it is given, okay, in the question that the sine is equal to, this is 100t. Okay, so according to the, okay, trigonometry, according to the mathematics, okay, we can ignore, okay, we can ignore, you know, this sine trigonometric function. Okay, if they are same, they are equal, okay, no need for the sine function. Okay, now directly I can write, okay, this is 2 pi f multiplied by the time, this is the time, okay, t, and here this is 100 multiplied by this is t. Okay, so the t is, the t is cancel out, and I need to find the value of the f. Okay, so this f is equal to, this will be 100 this side, and this will go to the other side. Okay, see here it is multiply, getting my point. Okay, this is multi 2 pi. Okay, the 2 pi is multiplied with the f. So if this is going to the other side, so what will happen, it will go to the divide means it will go down. Okay, so this is, okay, if I put the value of the 2 and if I put the value of the pi, so this will be 3.14. Okay, so if I calculate, okay, this number, and when you will calculate, okay, when you will calculate, so this, you know, the denominator should be in the bracket. Okay, so the value of this f will come approximately the 15 point something 9. Okay, and in the unit of the hertz. So this is the answer for the part C. Okay, and now we are moving to the, now we are moving to the other question. Okay, this is little a little difficult question because we have to take, the answer depends upon the data. Okay, the answer, the whole answer depends upon the, okay, the whole answer depends, okay, the whole answer depends upon the data which is given here. Okay, see, this is nothing, nothing is given here. Okay, so There is nothing is given in this, okay, in the statement. Okay, so all the data, okay, so all the data you have to read from, okay, from here. Okay, so you should be, okay, you should know how to read, how to read the variables from the sine wave. Okay, if you don't know what is what, okay, then it is little difficult for you. Okay. Okay, so now the one sine wave is given. Okay, on the y-axis. Okay, on the y-axis the voltage is given. Okay, this is always plus side, and this is always minus side. Okay, this is 0, and this is given time. Okay, so actually particularly in this diagram it is not given. It's actually it should given it is given here unit. Okay, so actually I want to say the unit. Okay, so the unit is given, okay, in the data. So the time here it is taken in millisecond. Okay, so now they are asking, okay, so the figure shows an AC voltage signal. Okay, this is the AC voltage signal, okay, shown here, and calculate the following values given in the figure. Okay, so the first thing is the maximum voltage. So the solution for the, okay, the solution for the maximum voltage. Okay, so we need to find the value of the maximum voltage. Okay, before that I will tell you one thing. Okay, now, okay, so how many voltages we are using? Okay, so normally, okay, normally if I make this sine wave, okay, and here this is the plus voltage and this is the minus voltage, and this is coming 0, and for example this is coming say 10 volt. Okay, and here this is coming plus 10 volt, and for example it is coming minus 10 volt, for example this, okay, like that. So okay, so like from this maxima, okay, sometimes we are saying the maximum, or sometimes we are saying the peak. Okay, this is a peak of the, okay, this is a peak of the wave. This one is a maximum. Okay, plus it is a plus peak, and here this will be the minus maxima to the other side. Okay, or there is another name that we say it is a peak of the signal, peak of the wave, peak of the cycle. Now, okay, so this is 0. Okay, this is 0 volt here. Now it is, okay, like from, okay, like from, okay, now from here to here. Okay, so from this line to, okay, from this line to this axis line, 0 line. Okay, it is a 0 line. Now from this point to this point, this is known as a maximum voltage. Okay, or sometimes we are saying this is a peak voltage. It is the same meaning. Okay, so here, okay, so if I say what is the value of the maximum voltage, so I will say this is 10 volt. Okay, so the same if I am going to the opposite side. Okay, so if I say the peak voltage is plus 10 volt and the peak voltage is minus 10 volt, so this minus and the plus means only the direction. Okay, like the voltage signal is up, or if I say this is minus, okay, so the meaning is it is down. This is only the meaning of when I say this plus 10 volt, and if I say it is minus 10 volt. Minus means the signal is running downside, okay, to this reference line. This is the timeline, and the signal is down. This is the only meaning. Otherwise there is no, like, it is not a kind of the mathematical not plus minus like that. Okay, so here this is a peak voltage we are saying, and from, okay, from one maxima to other maxima. Okay, so like this maxima is coming here, okay, to the other side. So if I, okay, so if I read from, okay, see my arrow here. Okay, and from this arrow to this arrow, okay, from here to here. Okay, this is known as, okay, this is known as peak to peak. We are writing like this, peak to peak. Okay, so peak to peak means, okay, peak to, don't take this sign. Okay, don't take this sign. Okay, so just what we have to do, like from here to here. Okay, from here to here, this is 10 volt, and from peak has no direction, no such kind of directions. Okay, So it is okay from here to here. How much? It is again coming 10 volt. So this 10 volt and this 10 volt. So it is coming. It will come 20 volt. Okay. So the value of the peak to peak voltage is coming. It is coming 20 volt. Okay. So the relation sometimes. Okay. I have to find the maximum voltage. So the maximum voltage is okay most of the time this is a half of the peak to peak voltage. Okay, if I say peak to peak is how much? It is 20 and then it is divided by 2. So this will come 10 volt. Okay, so the meaning is the maximum voltage, okay, the maximum voltage is 10 volt. Okay, like this. Okay, so this will be okay just as a I'm okay as an example I'm telling. Okay, so now we are going back. Okay, so the same thing we have to uh, okay do here in the question. Okay, just the idea of the maximum voltage and peak to peak, something I told you. Okay, as example. Now here, okay, so now we are coming to the signal which is given to us. Okay, this is a signal which is given to us. Now okay, so now they are asking, okay, now they are asking what is the value of the maximum voltage. Okay, so where is the maximum? This, okay, what data given here? This value is given here. Okay, so this value means what? Okay, this is the value it is given by this arrow. Okay, from this arrow and this arrow. Okay, so it is 150 volt. Now this is what? Okay, so I know this is the plus. Okay, so this is the plus maximum and okay somewhere here or maybe okay somewhere here or maybe somewhere here. Okay, and this is the okay this is a negative side maximum, other side, or you can take this. Okay, so the meaning is this is the voltage between this and this. Okay, so okay, so what I told you, okay, in the rule, basically this is a peak to peak voltage. Okay, so what it is given to you? Okay, so what it is given to us? Okay, in the diagram it is given to us the value of the peak to peak voltage, which is 150 volt. It is given to us. Okay, now they're asking what is the value of the maximum voltage. So I can find the maximum voltage by okay by making this peak to peak half. Okay, so this will be 150 volt divided by 2. So it is equal to 75 volt. So the meaning is the maximum voltage is equal to 75 volt. Okay, so this is the answer here. After that, okay, they're asking, okay, they're asking what is the value of the RMS voltage. RMS voltage, if I know the maximum, okay, so the maximum voltage how much coming? The maximum voltage is coming here 75 volt. Okay, so we calculated. Now the RMS voltage, okay, so RMS voltage we can easily find by using the formula. This is the maximum. Sometimes we can write not max, sometimes if I write vm, it has the same meaning. Okay, so v maximum, m or max. Okay, so it is divided by root 2. Okay, so if I write here 75 divide by root 2. Okay, so this will give me the answer. Okay, so now if I calculate in my calculator, so this will give me the value of the this will give me the value 53 volt. Okay, 53 volt. So I'm going to the next page. Okay, and so here this is the solution of the B. Now they are asking what they're asking. They're asking what is the value of the VRMS. Okay, so the first you have to write the formula for the VRMS. Okay, and this is maximum. Okay, divided by root 2. So the value of it will maximum value is coming 75 and it is divided by root 2. So this will give you the value of the approximately value. It will give you the 53 volt. Okay, so this is the value of the VRMS answer. Okay, now after that, okay, so after that, what is the value of the angular frequency? Okay, so angular frequency means what? Angular, not a f. Okay, angular frequency means omega. You have to find the value of the omega. Okay, So we have to find the value of the omega. So this is the C part. So here we have to find the value of the angular. Okay, we have to find the value of the angular frequency. Angular frequency means what? Angular frequency means we have to find the value of the omega. Okay, and the omega is what? The omega is, okay, directly you cannot find the value of the omega. Directly we cannot find the value of the omega from the signal. Okay, first I have to find the frequency or the time period, then we can find. Okay, so okay, so this is 2 pi f. Okay, and this is 2 pi f, and I know the frequency is 1 over time period. Okay, so I'm replacing this f by 1 by t, so this will be 2 pi over t. Okay, so the formula I'm going to use here for the angular frequency, this is omega. Okay, so this is the rule I am going to use here. Okay, so what I need, I need the time period of the wave. Okay, so what is the time, what is the time period? What is the time period? The time period is the time of the one wave. Okay, so if I draw like this, okay, if I draw like this, so the time period is a time. Okay, this, the time period is a time of the one wave. This is the one wave like this. Okay, so I have to go back to the, okay, to the diagram of the signal, and I will, okay, so here I will, okay, okay, so I will erase something from the diagram so this will be more clear. Okay, now we have to, okay, what information is, okay, what information is given here regarding the time period. Okay, some information is given here. Now it is what it is given here, they have written like this. Okay, this is 0 0.5 millisecond. Okay, so this is the value. Okay, you know, I will come to know how, I will come to know like which number is what. Okay, which number is what, like this number is what and this number is what. Okay, because they are writing here voltage. Okay, so it's voltage, they're talking about the voltage. Okay, so here it is with the number, it is written millisecond, so the millisecond means they are talking about something, the time. Okay, so they are the, this picture is showing like the value of this point. Okay, the value of, okay, the value of this point is coming as 0 0.5 millisecond at this point. Okay, so it is starting from 0 second. Okay, starting from here to here. Okay, so if I draw the line like this, okay, this is what, this is a one cycle. Okay, and this is the one cycle, and the time of the one cycle is 0 0.5 millisecond like this. Okay, so this information I got from the graph, and okay, from this signal. And so the value of the time, okay, the value of the time period, okay, it is coming 0 0.5, it is coming millisecond. Okay, so the even millisecond you cannot use, so you need to change to the second. Okay, so the, if you are changing to the second, then milli means it is 10 to the power minus 3 second. So this is the value of the t. Now we have to go back. Okay, now we have to go back to omega formula, and okay, this formula I'm talking about. So this is 2, and the value of the pi is 3.14, and divided by 0. Okay, 0 0.5 multiplied by 10 to the power minus 3. Okay, keep in the bracket, and when you will find, okay, when you will find the value of this, it will come little bigger number. Okay, this is around 12,000 uh, 560. Okay, what is the unit of this angular frequency? The unit of this angular frequency is radian. Okay, this is the radian over second. So this is the answer for the part third. Okay, after that, yeah. After that, there's a one more part. Okay, so they are asking what is the function of the voltage, okay, with the time. So they are asking what is the value of the voltage like this. Okay, this is what type of the voltage. Okay, so I told you, okay, so I told you before, if they are saying the function of time, okay, the function of something, okay, the function of find the value of the voltage which is a function of the time, something like this. Okay, so the meaning is they want to ask, okay, they want to ask the voltage which is a function of the time. Okay, and this kind of voltage is a instantaneous voltage. Okay, what is the name of this voltage? This is a instantaneous. Okay, this is an instantaneous voltage, and I need to write the formula here. And the formula for, okay, and the formula for this is the V maximum. Okay, this is the V maximum, and then multiply by sine, okay, 2 pi f2, or you can write this omega t. Okay, so this is the formula for the voltage, okay, as a function of time, as a function of or time, function of time, or the instantaneous voltage. Okay, now what we have to do, just we have to keep the data here. Okay, so what is the value of the V maximum? So already we found before the value of the V maximum, okay, it is coming to 75 volt. Then this number, okay, we have to keep here. The value of the maximum voltage is coming 75, then it is sine. Okay, and now we have to now we have to keep the value of the angular frequency. Now we found the value of the angular frequency is this one. Okay, 12,560. So this value I will write here. Okay, this is 12,560 and multiply by t. Okay, so this multiply by t. So this is the answer here.